The 2005 Electrical Code contains clarifications that can be helpful in interpreting ELEC code cycles. It's a resource an inspector can use to gain a better understanding of the intent and application of rules, even if those rules were present in prior editions. The 2005 code includes updated and clarified regulations, including those related to the specific height of circuit breakers in a panel. One area where the 2005 code might be useful is understanding the requirements for working clearances around electrical equipment. While other codes addressed working space, the 2005 code may offer more specific guidance on maintaining adequate space for personnel to safely operate and maintain equipment. This can be particularly relevant when assessing existing installations that may not have been installed to current standards. Another example could involve the interpretation of grounding and bonding requirements. The NEC addresses grounding and bonding extensively, but the specific language and examples used in the 2005 code may provide clearer explanations of these critical safety measures. This could be useful when evaluating existing systems to ensure proper grounding and bonding techniques are in place. Furthermore, the 2005 code may offer enhanced clarity on the requirements for surge protection devices. While surge protection wasn't a new concept, the 2005 edition could contain more detailed information on the types of surge protection devices suitable for different applications and the proper installation methods. This is important for protecting sensitive electronic equipment from voltage transients. The 2005 code might provide greater detail on the requirements for arc fault circuit interrupters or SIs. SIs are designed to protect against fires caused by arcing faults in electrical circuits. The 2005 code may clarify the specific locations where SIs are required and the types of circuits that must be protected. For example, the requirements for kitchen circuits, bedroom circuits, and other specific locations may be more clearly defined in the 2005 edition. The code may also offer improved guidance on the installation of ground fault circuit interrupters or GFCIs. GFCIs are designed to protect against electric shock by detecting ground faults in electrical circuits. The 2005 code may clarify the specific locations where GFCIs are required, such as bathrooms, kitchens, and outdoor areas. It might also address the testing and maintenance of GFCIs to ensure their continued effectiveness. Additionally, the 2005 code could contain more explicit information on the requirements for conductor ampacity and overcurrent protection. Determining the correct conductor size and overcurrent protection for a given circuit is crucial for preventing overheating and fire hazards. The 2005 code may provide additional tables, examples, and explanations to aid in these calculations. The rules related to the installation of specific equipment, such as generators, transformers, and motors, may have been clarified in the 2005 code. This could include information on the required clearances, wiring methods, and protection devices for these types of equipment. Inspectors should always verify with the local authority having jurisdiction about which code cycle to use. The 2005 code may provide valuable insights into the intent and application of electrical safety regulations. While it's essential to adhere to the code cycle in effect at the time of installation, understanding the clarifications and updates in later editions can aid in interpreting and applying the rules effectively. When evaluating existing electrical systems, inspectors should carefully consider the code cycle in effect at the time of the original installation. However, referencing subsequent code cycles, such as the 2005 edition, can provide valuable context and clarification on the underlying safety principles. In addition to the specific examples mentioned, the 2005 code may contain numerous other clarifications and updates that can assist inspectors in their work. It's essential to have a thorough understanding of the code cycle in effect at the time of installation, but also to be familiar with subsequent editions to gain a broader perspective on electrical safety regulations. Inspectors might reference the 2005 code to clarify requirements related to the installation of low-voltage systems. This could include systems such as fire alarms, security systems, and communications cabling. The 2005 code may provide specific guidance on wiring methods, overcurrent protection, and grounding requirements for these types of systems. Another area where the 2005 code may be helpful is in understanding the requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. The 2005 code provides detailed classifications for hazardous locations and specifies the types of electrical equipment that are permitted in each class. The 2005 code may also offer clarification on the requirements for renewable energy systems, such as solar photovoltaic or PV systems and wind turbines. This could include information on the proper wiring methods, grounding requirements, and disconnect means for these systems. Renewable energy systems are becoming increasingly common, so it's important for inspectors to be familiar with the relevant code requirements. The 2005 code could provide more specific guidance on the requirements for energy efficiency. This might include regulations on lighting controls, motor efficiency, and building automation systems. Energy efficiency is an important consideration in modern electrical design, and the 2005 code may reflect this emphasis. The 2005 code may offer enhanced clarity on the requirements for temporary electrical installations. Temporary electrical installations are often used during construction projects, special events, or emergency situations. The 2005 code specifies the safety requirements for these types of installations, including the use of GFCIs, proper wiring methods, and adequate overcurrent protection. The 2005 code may also clarify the requirements for electrical installations in healthcare facilities. Healthcare facilities have unique electrical needs due to the presence of sensitive medical equipment and the need to protect patients from electrical shock. The 2005 code provides specific regulations for electrical systems in these facilities, including requirements for isolated power systems, emergency power systems, and grounding. The code may also offer improved guidance on the installation of communications systems. Communications systems are becoming increasingly important in modern buildings, and the 2005 code may address the specific requirements for these systems, including wiring methods, grounding, and bonding. Inspectors may refer to the 2005 code for clarification on the requirements for swimming pools, spas, and hot tubs. These locations pose unique electrical hazards, and the 2005 code provides specific regulations to protect users from electric shock. This includes requirements for GFCIs, bonding, and equipotential planes. It is important to consult with the local authority having jurisdiction (OJ) on the proper code cycle to follow. The 2005 code may provide additional information on the requirements for industrial electrical systems. Industrial facilities often have complex electrical systems, and the 2005 code may address specific issues related to these systems, such as motor control centers, variable frequency drives, and process control equipment. The code could also clarify the requirements for electrical installations in agricultural buildings. Agricultural buildings often have unique electrical needs due to the presence of livestock, corrosive environments, and specialized equipment. The 2005 code may provide specific regulations for these types of buildings, including requirements for wiring methods, grounding, and bonding. When an inspector references the 2005 code, they should always be mindful of the fact that it may not be the current code cycle in effect. The most recent edition of the NEC should be consulted for the latest requirements. However, the 2005 code can still be a valuable resource for understanding the intent and application of electrical safety regulations. Firstly, inspectors can use the 2005 code to gain a deeper understanding of the underlying principles of electrical safety. The code is not simply a set of rules, but rather a comprehensive framework for ensuring the safe installation and operation of electrical systems. By studying the 2005 code, inspectors can develop a better understanding of the hazards associated with electricity and the measures that can be taken to mitigate those hazards. Secondly, the 2005 code can help inspectors to identify potential code violations in existing electrical systems. While the code cycle in effect at the time of installation is the primary reference, the 2005 code can provide valuable context and clarification. By comparing the existing installation to the requirements of the 2005 code, inspectors can identify areas where the system may not be in compliance with current safety standards. Thirdly, the 2005 code can be used as a training tool for new electrical inspectors. The code is a complex and technical document, and it takes time and effort to master it. By studying the 2005 code, new inspectors can gain a solid foundation in electrical safety principles and learn how to apply the code in real-world situations. Fourthly, a 2005 code can be a valuable resource for resolving disputes between electrical contractors and homeowners. In some cases, there may be disagreements about the interpretation of the code. By referring to the 2005 code, inspectors can provide an objective opinion on the matter and help to resolve the dispute. Fifthly, the 2005 code can be used to improve the overall quality of electrical installations. By promoting a better understanding of electrical safety principles, the 2005 code can help to ensure that electrical systems are installed correctly and safely. This can reduce the risk of electrical fires, shocks, and other hazards. The 2005 code contains valuable information on the proper selection and installation of electrical equipment. The code specifies the types of equipment that are permitted for use in different applications, as well as the requirements for installing that equipment correctly. This can help to ensure that electrical equipment is installed safely and reliably. The 2005 code can assist the inspector to interpret the requirements for special occupancies, such as theaters, assembly halls, and hazardous locations. Special occupancies often have unique electrical needs, and the 2005 code provides specific regulations for these types of occupancies. This can help to ensure that electrical systems and special occupancies are installed safely and in compliance with all applicable requirements. The 2005 code can assist in understanding the proper methods for grounding and bonding electrical systems. Grounding and bonding are essential for protecting people from electric shock and for preventing electrical fires. The 2005 code provides detailed requirements for grounding and bonding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding conductors to equipment, and the requirements for bonding metal enclosures. The 2005 NEC provides information on the proper methods for protecting electrical circuits from overcurrent. Overcurrent protection is essential for preventing electrical fires and for protecting electrical equipment from damage. The 2005 code provides detailed requirements for overcurrent protection, including the size and type of overcurrent devices, the methods for installing overcurrent devices, and the requirements for protecting conductors from overcurrent.